Alright, here we're going to talk about finding the percent of change, which is basically thinking about how much something's changing as a percent. It's really right in the name. It's the percent that describes the amount it's changing. Before we get into that, we're going to do this little intro with this bar graph, just thinking about how much does the graph increase. How much does it increase from 2005 to 2006? So going from 2005 to 2006, how much does that go up? So 177 minus 94, how much is that going up? Subtract those two and you find that it's going up, it's increasing by 83. That's how much it's changing. What's the difference between 2006 and 2007? It's asking the exact same question. Going from 2006 to 2007, what's the difference? Going from 317 to 177, what's the difference between those two numbers? That's 140. And the third one is asking what was the change from 2007 to 2008? What's the change between those 2 years? Between these two, from 317 up to 350. 350 minus 317 is 33. That is all talking about the change as a number. How much is it changing? The only extra step is to figure out what is that number as a percent compared to the original. It's the percent of change rather than just the amount that it's changing by. So the equation for percent of change is basically what we just did on the top of that fraction. It's the new one minus the old one divided by the original one divided by the old one times 100. The three intro problems were all just doing this part of it, the new minus the old. To change that into a percent compared to the original, all we do is divide that by the old one and times it by 100. This isn't actually as much to remember as you might think. To find percent of change, we do the new minus the old divided by the old times 100. The easiest way to remember that is you just see no on top. It's no divided by the old one on the bottom. You use this one twice, the old one gets used twice, and you see the word no on the top. So just reading that first question, Anna earned $130 last week tutoring her neighbor. She earned $60 this week. This week she earned $60. Find the percent of change from last week to this week. So first we really just want to use this equation to set that problem up. The new one, the new, this week, 60, minus the old one, last week, 130, divided by 130 times 100. You know it's the old one. You know 130 is the old one because that happened last week. 60 happened this week. So the time is really important here to decide the new versus the old. Another really important part of this is hitting equals after you do the subtraction on top. If you don't, it's not going to follow order of operations correctly. It's going to do the division before it's supposed to. So 16 minus 130 is negative 7. Make sure you hit equals there. You should get negative 70. Then you can divide by 130. That gives you this decimal of negative 0.538. I'm going to round that to a 5. It's really a 4, but then it's a 4.6. So I'm going to round that up to a 5. And then times that by 100. And I'm going to keep that rounding the same. I'm going to call that negative 53.85%. That is the percent of change. It went down, so it's a percent decrease. You can talk about it as a percent of change, a percent increase if it's positive, or a percent decrease like we see here, which is a negative. It's going down. You're not used to seeing negative percentages because in general you're talking about them as a part of a whole, but here we're talking about how much it's changing. This is going down from 130 down to 60. It's decreasing by 53.85%, or it's a negative 53.85% change. Oops. All right, on number 2, Jack had 54 subscribers last year. That's going to be my old one. That's last year. This year, that's my new one. He has 100 subscribers. Find the percent of change from last year to this year. So we're going to use the new minus the old divided by the old times 100. The new 100 minus the old, which is 54, divided by the old one. Remember, we used the old one twice. That's 54 times 100. 100 minus 54 is 46. 46 divided by 54 is 0.851. I'm going to call that 9. I'm going to round to that decimal place again. And then timesing that by 100 would change that into a percent. Right now it's a decimal that represents the change. I want to change that into a percent. By multiplying that by 100, that gives me 85.19%. That one's a positive because it's going up. It's going up from 54. It's going up 85.19% to 100. The next one's tricky only because they use percentages in the problem. On the first quiz of the year, 40% of students earned an A. On the last quiz, 60% earned an A. So it's going from 40%, that means that's the old one, to 60%, that's the new one. We want to find the percent of change from our first quiz to our last quiz. Again, it's new minus the old, it's no on top, divided by the old one, times 100. The new one is 60, the old one is 40, and we use the old one twice. 60 minus 40 is 20, divided by 40. Again, make sure you hit equals after you do this part. You can't just subtract and then do the division all in the calculator in one step. You have to hit equals there to get 20, then divide by 40, which is 0.5, and then times by 100, which gives us 50%. Hopefully that really makes sense. It's a 50% increase from here to there. It's increasing by 50%. Half of the people, it's a gain of half of these people. Half of that is 20, and it's gaining that much to get up to 60. Number 4 is saying 1980, a gallon of gas cost $1.19 versus 2017, where a gallon of gas costs $2.40. This is our old, this is our new. We want to find the percent of change going from 1980 to 2017. The new minus the old, divided by the old one, times 100. The new minus the old gives us $1.21. Divided by $1.19 times 100. When you do this division, you get 1.0, I'm going to just call that 2. 1.02 times 100. I times that by 100, that gives me 102%. Whoa. 102%. I'm going to completely repeat that one. 102%. Which again should make sense. What that's really saying is that it's going more than double up from what it was. From this, it's about doubling to get up to that. It's increasing by $1.21, which is about 100% increase. All right, on the next page, we see a graph that's showing the rainfall, the monthly rainfall, in inches from April to July. So each of those dots shows how much it rained in a different month, in April and May and June and July. What's the percent of change from April to July? So again, we're using that same equation, percent of change. Anytime you see that phrase, percent of change, percent of increase, percent of decrease, and actually like percent of markup or percent of discount are kind of the same thing. You're trying to find the percent that it's changing by. Either way, for any of those, you're going to use the new minus the old, divided by the old, and times 100. The new one, the most recent one, is July. That's the latest month there. So that's 1. Minus the old one, that's April, which is 6. Divided by the old one, the original one, which is 6, times 100. 1 divided by 1 minus 6 is -5 over 6 still, times 100. -5 divided by 6 is -0.83 repeating, and times that by 100. It moves the decimal place 2 places to the right. That becomes -83.83% repeating again. And it's a decrease, so it's a negative number. It's going down from April down to down to July. That's decreasing by 83.3%. What's the percent of change from May to June? Going from May to June. The newer one here is June. That's our new month. This is our old month. So June minus May over May times 100. It's the new minus the old divided by the old times 100. 4 minus 3 is just 1 divided by 3 times 100. 1 divided by 3 is 0.3 repeating. And that number times 100 is 33.3%. Again, repeating. That's positive because we're going up. From May to June, that's increasing, so that should be a percent of increase or just a positive percent of change. All right, the next one is kind of asking us to interpret a percent of change answer. Which consecutive months? Consecutive months are just 2 months in a row, so like April and May, or May and June, or June and July. And so those are all the combinations that we could possibly use. So the 2 months in a row that have the biggest percent decrease. So I'm talking about going from April to May, that percent of decrease. Going from May to June, I can rule that out right away. That's a percent increase. That's going up. I know that's not it. And the next one is June to July. That's actually going down. So I have to compare those two decreases. So I'm going to do the new minus the old for each of those combinations. The new minus the old. For the first one, it's May minus April, divided by April. So May minus April. That's -3. It's 3 minus 6 over April, which is 6, times 100. That's going to give you -50%. Same kind of thing for June to July. So from June to July, what's the percent of decrease? I'm going to do the exact same thing. It's July minus June over June. July is 1. June is 4 over June, which is 4 again. That's negative 3 over 4 times 100. And that's going to give you a negative 75%. That's the bigger percent decrease. Even though they decrease by the same exact amount, negative 3 and negative 3, they decrease by the exact same amount. The percent of decrease is different because the original amount was different. Here, the original amount was 4. Here, the original amount was 6. It's decreasing by a bigger percentage of the original amount. All right, these last 4, actually, we've done problems like this. You're using a percent just to find a new amount. So in my 4th game, I threw 5 touchdown passes. My touchdown passes decreased by 40% in my next game. How many touchdown passes did I throw in my 5th game? I actually don't want to use the percent of change formula for this. I'm told the percent of change. I know exactly how to use that in a proportion. I'm just going to go back to proportions and use my 40% over 100. And I'm comparing that to the original amount. I'm talking about my 4th game as the original amount. That's 5. I want to figure out how many less touchdown passes I threw. This is talking about how much it's decreasing by. When I solve that proportion, I get 2. But that's not my answer. I'm trying to figure out the final amount of touchdown passes I've thrown in my 5th game. Well, I threw 5 in my 1st game. Sorry, my 4th game, really. I threw 5 originally, and it's decreasing by 2. So my 5th game, I threw 3 touchdowns. Number 9 says that Bella collected 52 butterflies for her science project on Saturday. On Sunday, she collected 25% less butterflies. How many butterflies did she collect on Sunday? So again, I want to find the new amount. I'm just going to use that percent. 25% over 100 equals some amount out of the original 52. That's going to tell me how many less. Again, this is talking about the decrease. How many less butterflies she caught on Sunday versus Saturday. When you solve that proportion, x is 13. So Bella caught 13 less on Sunday compared to Saturday. On Saturday, she caught 52. So 52 minus 13 tells us she caught 39 butterflies on Sunday. On number 10, it's saying it snowed 2 inches in January. If there is a 350% increase in snow in February, how many inches will it snow in February? Same exact process. I'm talking about a percent. That's always going to be over 100. The original amount is 2. That's talking about January. The original amount always goes on the bottom. That's why the 100% goes on the bottom. That's the original percentage, or the whole percentage. I want to figure out how much it's increasing by. When I solve that proportion, I get that x is 7. That is how much it's going up by. That's not the final answer. It's increasing by 7. So it gets up to 9 inches in February. The last one, you were paid $52,000 for working your first year out of college. In your 5th year, you earn a 15% pay increase. Same exact process. We're talking about a percent out of 100. The original amount still goes on the bottom. We're trying to find out how much that pay increase really is. So we're solving for this. That's talking about the increase, which here happens to be $7,800. Your pay is going up by $7,800 from where it started. This plus this tells us your new amount of money that you're making each year, which is $59,800. Always read what the question's asking for. If it's just looking for how much it's increasing by, then you'd be done at this step. If it's looking for the final amount that you're making, then you're looking to add those together and get $59,000, almost $60,000, $59,800.